The scale of automated probing. OpenAI's internal GPT-Red model is now outperforming human security researchers by a factor of 6 in discovering critical prompt injection vulnerabilities. According to the technical report released on July 15, 2026, this automated attacker achieved an 84% success rate in indirect injection scenarios where human experts peaked at only 13%. By dedicating over 700,000 GPU hours specifically to adversarial training, OpenAI has shifted the security bottleneck from human creativity to raw compute. This isn't a static set of test cases, but a dynamic agent that iterates toward a malicious goal by monitoring model responses and adjusting its strategy in real time. This volume of synthetic attack data is what allowed the recently released GPT-5.6 Sol to show a 6-fold reduction in injection failures compared to models from just 4 months ago. And the mechanics of this improvement depend on a specific adversarial feedback loop. Reinforcement learning as an arms race. The core mechanism of GPT-Red is a self-play reinforcement learning cycle that pits an attacker model against a collection of diverse defender models. The attacker earns rewards for eliciting a valid failure, such as tricking a system into exfiltrating AWS credentials or disabling two-factor authentication. Simultaneously, the defender models earn rewards for resisting these attacks while still successfully completing their original user tasks. This dual objective reward function prevents the defenders from simply refusing every query, which is the easiest way to pass a safety check but ruins model utility. As the defenders harden, the attacker is forced to discover high-dimensional bypasses that look like nonsense to humans but trigger specific latent activations in the transformer layers. This creates an escalating loop where each side effectively trains the other without human intervention. This process recently surfaced a novel attack vector that most human red teamers missed: the fake chain of thought discovery. During these automated runs, GPT-Red discovered a specific vulnerability OpenAI is calling fake chain of thought attacks. In this method, the attacker plants a false reasoning step that the target model treats as an already verified fact, such as convincing the model it has already performed a security check that never actually happened. Before this discovery, these attacks worked on 95% of GPT 5.1 instances, but automated training has driven that failure rate below 10% on the current flagship. However, there is a clear mechanical ceiling to this approach. GPT-Red still struggles with multi-turn social engineering and image-based injections, areas where human testers still maintain a significant lead. This suggests that while compute can solve for structured technical vulnerabilities, it lacks the context required to model human psychological manipulation. This gap between technical hardening and socio-technical safety is the new front line for model alignment. The signal under the noise. The deployment of GPT-Red signals a transition from manual safety patching to systemic weight immunization. By integrating adversarial agents directly into the post-training pipeline, OpenAI is attempting to bake security into the model architecture rather than wrapping it in external filters. For developers, this means the era of simple prompt-based jailbreaks is likely ending as production models are now pre-hardened against millions of synthetic attack variants. But this immunization comes with a cost. We are seeing a measurable narrowing of model personality and a potential decline in non-standard creative reasoning, a phenomenon researchers are calling the alignment tax. As these models become mathematically robust against the 84% of attacks that GPT-Red can generate, they risk losing the flexibility required for complex, open-ended problem-solving. The next logical step to watch is whether this automated hardening leads to a performance plateau in the upcoming August model updates, where safety and utility may finally reach a zero-sum trade-off. Subscribe for more